Hey, welcome to this video. In this video, here I am going to explain working of DC generator. So now let's move on to the animation. So this is the frame. Inside this frame, we'll mount the poles. Once the poles are mounted, we'll place a shaft. On this shaft, we'll be mount a rotor, and in rotor, there is a rotor winding. Basically, it is known as armature in case of DC machine. So now let's move ahead. On this pole, we need to place a field winding which can be mounted like this. Once the field winding is done, we'll place commutator segment on the shaft. Once the commutator segment is placed, we'll place brush assembly on that commutator segment. Once the brush assembly is ready, we'll connect this brush assembly with terminal box. So finally our complete generator is ready. So now let us understand working of DC generator. To understand the working of DC generator, we need to give supply to the field winding. So now let's give current to this field winding. Once the current starts flowing, it starts producing a magnetic field. Initially, you have seen when there is no current flowing through the coil, there is no magnetic field. And when there is no magnetic field, no N pole and no S pole in the generator. But as current starts flowing according to the direction of current and according to the direction of magnetic field produced, one pole becomes N pole and another one becomes S pole. So now let us understand how the EMF will be induced in the generator. Basically, there are two ways to induce EMF. Those are statically induced EMF and dynamically induced EMF. In all rotating type machine, there is a dynamically induced EMF. Now if you want to produce EMF dynamically, there are three basic requirements of it. So first requirement is there has to be a magnetic field. Second, there has to be a conductor in that magnetic field. And third, there has to be relative motion between the magnetic field and the conductor. So now we'll be seeing two cases. So in case A, the magnetic field is static but the conductor is moving, and in case B, the conductor is static but magnetic field is moving. In DC generator, we will be applying case B. See, this is how it works. So in DC generator, where we'll be rotating the magnetic field and the conductor will be static. So basically this rotor will get mechanical input from the prime mover. So once prime mover starts rotating, this rotor starts rotating. So now let's quickly rotate this rotor. Once the rotor starts rotating, it starts producing EMF. The EMF is produced and the current starts flowing in the outward direction to the terminal box. So we are getting current as output, which is an AC current. So this is how we define a DC generator. It is a DC machine which converts mechanical energy into electrical energy. So now let me quickly repeat the complete working procedure. First of all, a supply is given to the film. Once the supply is given, current starts flowing, and because of that current, a magnetic field is produced. Once we start rotating the rotor into the magnetic field, rotor is rotating, and because of the relative motion between magnetic field and the rotating conductor, EMF is induced in that conductor and it is delivered to the terminal box. So this is how a DC generator works. We have come to the end of the video. Hope you have understood the concept of DC generator and enjoyed learning this. Please share and like this video, and thanks for watching.